A doubt asked from ratio proportion. A very familiar situation. The ratio of monthly incomes is 3:4. So ratio of incomes is known and the ratio of expenses is 4:5. And we need to find which of the following can be a ratio of their monthly savings. Incomes 3:4. If I change them into actual value of incomes, I'll have to use a constant. So let's say one guy's income is 3k, the other guys will become 4k, and expenses 4:5. It's another ratio, so I would have to use a new constant 4n, 5n, and we know from a familiar situation earlier that we cannot find this ratio of savings. Right, the value will depend upon k and n. So there are many possible values for the ratio of saving, and that is what the question is using to confuse you, right? Which of the following can be a possible value? There are many possibles, but out of these four, only one is possible, which can be possible. The smart ones capitalize on the fact that out of these, one of them is an answer. So one of these ratios is in some way unique. And what they can do is, how are they unique? To check, I'll just convert them into decimals. So I'll take 9/10, which is 0.9, 3/4, 0.75, and you should realize that 3/4 is also that of the income. Okay, and you know these smart ones, they use very common sense. So if they're earning 3:4, if they don't do anything, they don't spend anything, then the ratio will be 3:4. Right, but if they start spending, then it would no longer be 3:4. So somewhere they know that the savings is leveraged by the income. Right? Okay, 13/20 in decimal is 0.65, 4/5 is 0.8. So they are going to compare the ratios that we have with one known value. I know that the ratio of saving in an extreme situation can be 3:4, okay, or 0.75. Now I see that 0.9 is also greater than 0.75, 0.8 is also greater than 0.75. So again, they're taking a risk somewhere that this is what they're using as a reference to compare the others. They see two values is greater, this is less, so this is a unique one, and they would mark this as an answer and go ahead, students, without worrying about how watertight this reasoning is, right? And they do well in exams also, right? Okay, for the ones who depend a lot on pencil work and they want a perfect answer, they're not good enough with taking risk, then the only way out is you use the options, you equate them to various options, and you check out, do I get some let's say contradictions, do I get some absurd results, right? We have done one ratio earlier when we used to, very similar to this, how does a ratio of ages, how does it change over the years? Yeah, there's a video on that, you can watch it. There, when we cross multiplied, we got one of the constants as negative. Let's see what happens here. 30, 36k, so that leaves us 6k. Minus 40, this is minus 45, comes this side, is a plus 45. So this does not result into negatives, right, at the moment, right? So I get a relation between n and k, and I can very easily take this relation as, let me take n as 6p. Okay, there's nothing a ratio of n and k, right? So we take n as the other one and k as this. So k is 5p, right? When I rewrite these values in terms of p, the income becomes 3k, that is 15p. Okay, the income. The expense of the first guy is 4n, 4 6 are 24, 24p. Oh, here is that contradiction. How am I spending more than what I am earning? So I'm getting negative value out over here, so I know that this is not my answer. But let me just complete it. The ratio will eventually become 9/10 because both will turn out to be negative. 4k, 4 5s are 20p, 5n, 5 6 are 30p. You can confirm it that it has to be 9:10. Right? But the negative issue, the problem is that it is coming minus. Right? So what if I take the third one? 3k minus 4n over 4k minus 5n is 13/20. It is in the reduced form. 60, 52. 52, 60. So that gives me 8k minus 80. and this is a 65, minus 65. So 80 goes on this side, we'll get a 15n. Similar result as the earlier. You can quickly do k. Let me take k as 15p. Let me take n as 8p. Okay, rewriting the numbers, 3k, 1545p is the income of the first 4n. 4 into 8, 32p. So is this fine enough? Yes. From 45p he can spend 32p. Okay, and and the leftover will be 13p, right? If you check the denominator, 60p income. If you subtract 5n, 540p, this is also fine. In expenses less than income, and the ratio is turning out to be 13:20. Easy enough, right? So the textbook way, but it will require this sort of pencil work. There are two more ratios that I did not check. You can check it. Those are in fact unique students. There also there's a learning opportunity. Tell me if this ratio is equal to 3/4. We have done that earlier also. When will the income be same as savings? The ratio only when the expenses are 0. If you want, do it. 4 3s are 12, 4 3s are 12. So the k and k will cancel out. This is minus 16 and this is minus 15. So it goes on to the other side. I'll be getting n as 0. N as 0 means there are no expenses. If there are no expenses, how can the ratio of expense be 4:5? When we say the ratio of something, it is present. Yeah, if it is not present, you can't find a ratio. Ratio is a comparison, right? So this won't work. And here also you are going to get the same thing. So if you make this 4/5, by the reverse logic, this ratio is 4/5. This is also 4/5. The only way it can happen is when this is 0. Check it out. 5 3s are 15, 4 4s are 16k. So that leaves out a k. This is minus 20, minus 20. That cancels out and you get k is 0. So you know this is also not possible because there are some incomes, right? So this is the whole the smarter way to find the answer. And also if you are dependent on writing, how do you find? Now let's take this question as an opportunity to know what happens that less than. Oh, I take 0.75. How do I know that when I subtract two values in the ratio 4/5, I'm going to get a value less than 0.75 or I'm going to get a value more than 0.75? Let's do it. It's a nice theory, right? So I'm pretty sure you know from law of equal ratios that if I have two quantities, let's say in the ratio 3:4, these are two quantities, the ratio becomes 3:4. And I have another quantities also. They are also in the ratio 3:4. Okay, now, so do I know that this ratio is equal to this ratio is equal to 3/4? Right? Now, law of equal ratio says this is equal. If I do the subtract, if two ratios are equal and I subtract the numerators 3k minus 3n and the denominators also 4k minus 4n, this value will also be equal to 3:4. Now this is from law of equal ratio, so I'm not spending time here. If a by b is equal to c by d, then a minus c over b minus d will also be equal to them if they are equal, right? I'm banking on this if they are equal. So if it is 3/4 and 3/4, I know that when I subtract them, the result will be 3/4 itself. Now let's take this comparison. Okay, so if, let me put this down also. If then 3k minus 3n over 4k minus 4n is 3/4. But what happens if I subtract two values? Okay, I'm subtracting two values, one from the numerator and one from the denominator. And these two values, the ratio of them is more than 3/4. More than 3/4. Now think carefully, right? If it was 3/4, then the result should also be 3/4. If this is more than 3/4, so think compared to a reference 3/4, this is more. One easy way to think is the numerator is more. So you're taking away from the numerator a larger chunk. So the taking away, why? Because you're subtracting. Is it okay? So whatever is going to be left will be less than the reference. So the answer is going to be less than 3/4. Right? And all you need to check here is this expenses. The ratio of expenses is what? Is 4/5. Are we together? 4/5 as a ratio is what? 0.8. Is 0.8 more than 3/4? So the result has to be less than 0.75. As easy as that, students. Okay, and hope you get that. So it is a little tough for those who don't like maths. Those who can do mental maths very fast, it's very easy. So for those who find it tough, I'm again saying I'm starting from a reference. So I'm saying if the things that I'm subtracting are in the ratio 3/4, then my answer ka reference, the answer will also be 3/4. I am subtracting something more than 3/4. More than 3/4, one way of looking at it is the numerator is bigger than the reference, right? And so I'm taking away bigger chunk. So what is left will be smaller than the reference that I would have expected as the answer, and therefore my answer is less than 3/4. Let's do a couple of them. You can, the example to here, you can yourself do it, right? So let me take some values here. So example, check. And you can do this check. This check is for those who find it difficult. Take two values here such that I can subtract this. So I'll not take them 3 and 4, I'll take them 6 and 8. Okay, and can I subtract a 4 and a 5 from them? I did not take them 30, 40 because I want to be able to find this. Okay, so let me check this. What do I get? 2, and what do I get? 3. Right, 2/3 is what? 0.66. So have I got less than the earlier one? Yes. And that is enough for me to say this is going to be my answer. You could have just done this much also if you don't want to do a lot of risk taking, right? What if I am subtracting a value less than 3/4? Obviously the opposite is going to happen, but let's reason out. If I had subtracted 3/4, my answer would be 3/4. I'm subtracting less than 3/4. One way of thinking about it is the numerator is less than the reference. Oh, so I'm removing off something less than the reference. So the result, the numerator will be more than my result ka reference. So result reference was 3/4. I'll get more than it. More than 3/4. Right, so don't mug it up. Do this thought process in your mind. Do as a check. Okay, so I want something more. I don't want this. So if this was not the ratio 4/5, this is what? 0.75. And let's say this is 7 and 10. What happens with 7 and 10? The ratio becomes less than 0.75. It becomes 0.7. Oh, so I'll just take, let me take a third value for this, right? So 6 and 8, 6 I can't subtract a 7 from 6. So let me take 3. 9 and 12 are the incomes. And the expenses are 7 and 10. So what do I get? I get 2/2. So the ratio becomes 1/1. 1. 1 is more than 0.34. Is that okay? So you can do this check also. So remember, you could subtract. Sometimes that could be addition also. So I could have given you savings and expenses and I could have asked you income. So what happens? Income is equal to expense plus saving. So please remember, I'm now taking just continuing the theory. I'll take a improper fraction. Okay, so I'm taking a bigger value in the numerator, 7/5, randomly. So one ratio is 7/5 and I'm adding this time, students, some numbers to it, to the numerator and denominator. And these two numbers that I add, I'll give you the ratio of them and you have to tell me the result. Will it be more than 7/5 or less than 7/5? Okay, so let's say, what was the reference that I'll say? What is this ratio? 1. You'll have to compare ratio, it's better to come to numerical value, right? Decimal value. This is going to be a 1.4. So what if I subtract a ratio, let's say randomly I can take 5/6. Now, the ratio of these two quantities is 5/6. Oh, if it was 1 by 1.4, I would have got 1.4. But this is less than 1.4. Oh, that means the numerator is less than the reference that I was adding. Okay, if I'm adding less, the result that I should be getting is also going to be less than the result. What was the result? Less than 7 by 5. You want to do a check. So if I add 5 and 6 itself to this, 7 by 5, if I add a 5 and a 6 to this, right? So 7 and 5 is 12, 6 and 5 is 11. If you take the numeric value here, this is going to be 1.090909. Is it less than 1.4? Yes, it is less. And on the contrary, if I was adding a 3 by 2, what is 3 by 2 ratio? 3 by 2 is a 1.5, which is more than 1.4. Okay, if this was 1.4, I would have got 1.4. Okay, I would have got 7 by 5. Oh, but I'm adding more than 1.4. Oh, the numerator is more than the reference. Oh, so the result also, the numerator will be more than the reference. So I would not get 7 by 5. I will get more than 7 by 5. Check, let's add a 3 and 2, let's add. So 7 plus 3 is a 10 and 5 plus 2 is a 7, and I bet you know this is 1.428, which is definitely more than 1.4. So can you do these works in your mind? Yes, you can do, right? So hopefully this gives you a little more insight into when you add sort ratios, two different ratios, and you're sort of adding them or subtracting them, then in which direction will the result be? Thank you.